There will be about 40 to 60 of those that develop each year. However, we normally have, on average, only about 11 hurricanes each year. So obviously, most of those don't ever develop any further than that. If they continue to develop, then they get a closed circulation, and they're called a tropical depression, and they're given a number. And they start with number 1 for the first one each year. And however many we had 15 tropical depressions, and then go 1 through 15. The next stage up is when the winds reach gale force, which is 39 miles an hour. At that point in time, the storm is given a name, and it is called a tropical storm.
A tropical storm can bring with it heavy wind and rain that can cause some flooding. But the real danger of a tropical storm is that it's only one step away from being a hurricane.
There's some little something that pushes a storm up to being a hurricane. We're not exactly sure all that's involved, but one thing we do know, there has to be conditions in the upper atmosphere that will take air away from the storm, because it flows into the storm at the bottom and rises up through the storm. And if there were not something to carry it away at the top, then it would eventually just collapse back down on itself. So you have to have warm water, and you have to have low pressure at the surface, and then aloft there has to be a wind flow that will carry all this rising air away. At that point in time, when those conditions are there, then storms can develop into a hurricane.
When a hurricane forms, it has 3 main parts: the central eye, the eye wall, and the outer rain bands that can extend more than 300 miles from the center of a large hurricane. This means that precautions must be taken, far from where the eye is predicted to come on shore. Within the central eye of a hurricane is a calm, clear area about 20 to 40 miles wide. This is surrounded by a dense wall of clouds known as the eye wall. The eye wall is the most dangerous part of a hurricane. It harbors the hurricane's most intense thunderstorms and strongest winds, often causing tornadoes. Once a hurricane forms, its strength is rated on a Saffir-Simpson hurricane scale, from Category 1 to Category 5. Category 5 hurricanes often have winds in excess of 150 miles per hour. But the category of a storm does not necessarily relate to the damage it may cause. Sometimes, even lower category storms can do a lot of damage.
But hurricanes do damage by 2 different ways. One is with wind, and one is with water. And water is oftentimes the more dangerous and damaging part. But hurricanes do a lot of damage with wind. The stronger the wind is, the greater the damage is. And actually the damage increases very rapidly as the winds increase. Most of the damage is from trees being blown down, either onto houses or onto people in cars. And by taking the roof off of a house, and then maybe the whole house collapses, or by damage to mobile homes. Mobile homes are very dangerous places in hurricanes. As far as water damage, if you live right on the beachfront or on the bayfront, the ocean rises as the hurricane comes inland, and can sometimes rise as much as 25 feet above normal. So this water coming in from the Gulf can wash away buildings, and obviously can drown people.
The combination of storm surges, forceful winds, tornadoes, and heavy rain make hurricanes one of the most powerful forces on the planet. In the past, it was nearly impossible to predict the movement of a hurricane. But today, advances in technology have made it possible to track hurricanes from their very beginning to when they make landfall. The National Weather Service in Brownsville keeps a close watch over the Rio Grande Valley.
We're going to pipe a balloon and send up an instrument which is called a radiosonde. It gives us pressure, temperature, humidity, wind speed, wind direction. So that's one of the main tools of the National Weather Service.
Yeah. And how high does the balloon travel?
About 15 miles.
15 miles. And what do you fill it with?
Hydrogen.
Hydrogen.
Hydrogen. We have a hydrogen room here. We always have spares. If a hurricane was to come, we have plenty of gas, so we're prepared for it.
During times of hurricanes, how many balloons will you send up?
Every 6 hours.
Every 6 hours?
Yeah. Normal conditions, 12 hours.
Okay. So, how long before we launch it?
How long before we launch it? 10 more minutes.
Okay.
There's my instruments. Yeah, Tawa, this is weather. Did I get some clearance for balloon release? Okay, thank you. So now we have clearance for the balloon release.
The balloons provide important information about atmospheric conditions, which are monitored 24 hours a day by the National Weather Service.
Now we also have radar, but radar is only a good tool after the storm gets close to land because we can only see out about 250 miles from the radar with the beam. But that's a very important tool as you get close to land. And now also we fly airplanes into hurricanes. That gives us information about where it's located, how strong the winds are, and how low the atmospheric pressure is in the center of the storm. And that's very important information about how strong the hurricane is.
Although an extremely dangerous job, flying into hurricanes provides crucial data that scientists use to build models that help them better understand the inner workings of a hurricane. With better understanding comes better forecasting abilities, and scientists at NASA have been at the forefront of design, development, and deployment of remote sensing spacecrafts to do just this.
It was not really until the invention of the satellites back in the early 1960s that we were really able to track hurricanes from their very beginning until they threatened land.
The new generation of geostationary environmental satellites designed by NASA and owned by NOAA provide half-hourly observations of the Earth and its environment. This, along with other satellites such as TRMM, help provide data to the National Hurricane Center, which can send out warnings to local weather stations around the country. Although hurricanes are destructive, they are a vital force of nature. They serve as an important mechanism of heat transfer from the tropics to the cold temperate climates in the north. Without hurricanes, the northern regions would get colder and the tropics would get hotter. For thousands of years, man looked up to the skies to predict oncoming storms. Today, we look down from the heavens. Technological advances allow us to track and monitor storms, but the question remains the same. Is the next storm going to be the killer hurricane? We can only wait and watch. If you would like to learn more about hurricanes or want to know more about ongoing research, visit the following sites on the internet.